Now that we have listed all the requirements for our application, I want to talk about databases because I think that this will be useful to understand what we need to build. So over here I have a diagram which is composed of three main entities. And just so you know, this diagram is called the schema of the database, and it is just a representation of all the various types of entities in the database with their relationships. So the first entity is called user, and it represents a user that is signed in with our application. And a user can create and manage any number of jobs. And we can think of a job as a data model that has four properties: a job ID, and then a UID, which represents the user that created that job, and then the job name and the rate per hour. Then for each job, a user can create any number of entries, and each entry will have an ID, a job ID, which refers to the job, and then a start time and an end time, and then a comment that explains what the entry is about. In addition to these entities, I have added some arrows, and these arrows represent the relationships between the entities in our database. So if we wanted to describe this relationship on the left, we could say that a user can have 0 to n jobs, but a job is always associated to one and only one user. Similarly, we could say that a job can have 0 to n entries, and an entry is always associated to one and only one job. So once again, this diagram is called the schema of the database, and the schema describes all the entities in the database and their relationships. On the other hand, down here I have created a sample snapshot that represents the jobs and entries that we have stored in the database at any one point in time. So here, for example, I have two jobs called blogging and promotion, and these represent the entries that I can see over here, just two of them actually. And then I have one entry for job 1, 2, 3, which is blogging, and then two entries for job 1, 2, 4, which is promotion. So once again, these tables represent a snapshot of the actual data that is in the database at any point in time. Now, if we get back to the list of requirements that we have specified over here, we could try to work out how to get the data that we need given this database. So for example, getting the list of all the jobs is simply a matter of reading out the jobs table that we have down here. However, if we wanted to show all the entries for a given job, we would have to know what the correct job ID is and then take only the entries that match that job ID. And more in general, depending on which operation we want to make, we might need to combine together data from different tables in order to get the result that we want. And when using relational databases, this is normally accomplished with a language called SQL, which is a domain-specific language that is used to query data inside a database. So by writing and executing an appropriate SQL query on the database, we can get the data that we need. Okay, so this completes my brief overview about relational databases. And relational databases are a very broad topic that could be the subject of an entire course in itself. And the reason I wanted to talk about them here is that in this course we will see how to use Firebase Cloud Firestore as a database. However, Cloud Firestore is not a relational database, and in fact it is known as a NoSQL database. And what this means is that we will need to learn how Cloud Firestore can be used to store the data that we need and how it is different from relational databases. But even if Firestore is not a relational database, we will refer back to this diagram because it is a good representation of the data that we want to manipulate. So our job will be not only to learn how to use Firestore in general, but to see how we can represent these entities and relationships in Firestore. Okay, so let's continue on the next video.